Okay, today we will talk about how to prepare AHU schedule. Okay, it is similar for the FC schedule as well. Okay, so when you talk about AHU schedule, you can see that there is a table consist of, you can say, supply air flow. Okay, then you have a fresh air flow, either treated or untreated. Okay, then you have a external static pressure. Then you will see that air on coil temperature, air off coil temperature. Okay, so this is the temperature across the coil. Okay, on coil and off coil. Okay, then you have a cooling coil capacity. Okay, it will be total cooling load and also the sensible load, right? Okay, then you have a chilled water inlet temperature, then you have a chilled water outlet temperature. Okay, then you have a chilled water flow rate, right? Then you have a power input. So this is the schedule for the AHU. So this schedule, how to calculate, how to prepare the schedule, that we are going to see. Okay, now I'm going to explain each and every component. Okay, whenever you see that in one space, okay, there is a space here, right? So inside the space, you have a lot of cooling load. Okay, there are, you can say that, heat components. Okay, so basically you can say that there is a heat from coming from the people. Okay, then heat coming from the lights. Then there are heat coming from the equipment. Okay, then you have a heat coming from through the floor, through the roof. Okay, through the partition, then through the glass. Okay, then you can say that there is a conduction. Then there is a heat through the exterior wall. Okay, so these are all the heat. So when you say that, if you go to the equipment schedule, when you say the total load, it is called the total heat basically. Clear? Okay, so you are going to calculate what is the total heat inside the particular space. So for that, you are going to calculate the equipment, right? Like say you have a fan coil unit or you have a AHUs. So that AHU or FCU, what will happen? It will remove the heat from the space basically. So to maintain the room temperature, whatever you require 22 degree or 24 degrees Celsius. So your equipment, cooling equipment, will try to remove the heat from the space and it will try to maintain the required temperature. Clear, right?
Yes, sir.
Okay, now you are going to find out what are the heats basically. Okay, so if you go to this component, you have a total heat and also sensible heat. Okay, so what do you mean by the total heat? It is nothing but sensible heat plus latent heat. Clear? So what is sensible heat? Sensible heat is nothing but dry. Okay, so if you talk about air, okay, you have a two type of air. One is the dry air, one is the moisture air. Clear? Moisture air is nothing but water vapor. The air mixing with water vapor, and when you say dry air, it is with the pure air without any water moisture content. Clear?
Yes, sir.
Okay, so when you say sensible heat, it is nothing but dry, the heat coming from dry. Okay, so when you say latent, the heat coming from the moisture, through the moisture. Okay, so you are going to calculate what is the sensible, you are going to calculate what is the latent. So when you add together, you will find the total load. So this is the formula. Okay, now we are going to see what are the components. Okay, like you can say that there are different components, right? So the light, when you say light, it is the sensible load because there is no moisture from the lights, right? So when you say that, when you switch on the light in your home, okay, what will happen? It will get heated up, right? Then it will start dissipate the heat. So that heat is purely sensible load, right?
Yes, sir.
Okay, when you talk about equipment, it is purely sensible load. Okay, and when you talk about people, okay, so the people, say for example, the people release sensible load and also he will release the latent load. Latent load, how it comes? Say for example, when he inhale, when he release that
Sweat.
okay, the whatever it is, so that release that moisture content, right? So the human body consists of both sensible load and moisture load, which is latent load. Okay, so here you have a two type of loads. Clear? Okay,
Yes, sir.
so when you talk about outside, when you talk about weather also you have a two type of load. You can say that there is a air mixing with water vapor and also you have a dry air. So whenever you talk about the envelope, so the envelope you will be having normally sensible load plus latent load. Clear, right?
Yes, sir.
Okay, so this is the total load you are going to differentiate. Okay, now how to calculate the heat from each and every component? Okay, there is a formula here. Okay, say for example, if you go to uh, the equation, it is called heat transfer rate. You are going to calculate how much heat transfer rate for each and every component. Okay, so what is the equation? You can say that Q equal, basic formula for the heat transfer, it is Q equal to mcb delta T. That you know, right?
Yes, sir.
Okay, so from that formula only they are going to derive for the different materials. So here you can see Q equal to U multiplied by A multiplied by delta T. So what is the U? It's the rate of heat transfer to the material. So whenever you talk about this one, there are heat which will pass through the material, right? When you talk about inside your room, okay, there are heat outside, that heat will come through the envelope, and you can feel that heat when you don't operate the air conditioning. After some time you can feel that heat, right? So the heat comes from through the envelope, okay, which comes from outside. Say for example, if you are in winter, you have a lot of cooling coming from heating coming from outside through the solar. But whereas if you see that during winter condition, you will feel lot of cold inside, right? Because that cold coming from outside to inside, because outside weather is very cold. Okay, so it pass through the whatever the heat, it pass through the envelope. So here if you see this equation, you can say that Q equal to UA delta T. A is nothing but rate of heat transfer through a material. Okay, there are different material. You have a concrete, you have a brick. So each and every material having a different U value. Okay, then area. Then you have a temperature difference, which is called outside and inside. What is the temperature difference? Assume that your temperature you want to maintain 24 degrees Celsius, and what is outside 46 degrees Celsius. So what is the difference? That is called delta T. Clear, right? So this is the heat gained through the glass. So this is the equation. Rate of heat transfer through the glass material. What is the U value? Each and every U material having a U value. What is the heat transfer through the glass material? Okay, what is the rate? So you have to calculate. Okay, then there is the area of the glass, then the temperature difference between indoor and outdoor temperature. So then you can calculate the heat gain through the glass. So similarly for the heat gain through the wall, okay, UA delta T. U is nothing but through the wall. Here it is through a glass. Okay, so here you can see QUA delta T, right? So here you can see that A is nothing but area of the wall, delta T equivalent temperature difference minus corrective
Correct.
equivalent temperature difference. This value you can get it from the carrier table, right?
Hmm.
Okay, then you can see that heat gain through the partition. Okay, so the same U formula UA delta T, rate of heat transfer through the partition. Okay, A is nothing but area of partition. Okay, then the temperature difference is outside temperature minus indoor temperature. Okay, minus 5 degrees Celsius for normal partition. Because when you talk about insider, it is not the same as outside temperature, right? So you will be minusing 5 degrees Celsius. Okay, and if you
Okay.
have a kitchen, you will add 50 degrees Celsius because it's a kitchen. Okay, heat coming from the kitchen. So you have a outside temperature plus 15, and for the kitchen partition, you can add 10 degree Fahrenheit. Okay, so this is the thumb rule, right? So this is the equation for the partition. Okay, then similarly for the heat gain through the roof, U A delta T. So when you say U, rate of heat transfer to the roof, A is the area of the roof, delta T is the outside temperature, like a dry bulb temperature minus indoor dry bulb temperature. Okay. Similarly, for the heat gain through the ceiling or floor, same equation, Q equal to UA delta T. U is nothing but rate of heat transfer through the ceiling. A is nothing but area of ceiling or floor. Delta T is nothing but outside temperature to the inside temperature. Okay, then heat gain through the infiltration. There are heat coming from outside to inside through the leaks, through the, say for example, through the wall leakage, like wall cracks, or through the closed door, the small gaps, right? So this is the
Yes,
heat
sir.
coming from outside. Clear, right?
Yes, sir.
So what are the heat when it comes from outside? You have both sensible heat and you have a latent heat. Okay, so the
Hmm.
sensible heat, what is the equation? CFM multiplied by delta T multiplied by 1.08. Okay, and for latent heat, CFM multiplied by delta T multiplied by 0.68. Okay, so I feel there is a mistake here in this equation. This should be nothing but delta H. It is like a moisture content. Okay, what is the moisture outside? Ah, yeah, yeah. See here, delta T. Okay, you can see there. Delta T, this delta T is nothing but outdoor humidity ratio minus indoor humidity ratio for the latent, because it is a moisture, right?
Hmm. Okay, sir.
Okay, when you talk about sensible heat, actually supposed to be this delta H. Okay, it's not. It should not be delta T. It should be delta H. Okay, so you're calculating what is the sensible heat gain and what is the latent heat gain. Okay. Similarly, heat gain through the ventilation air. There are ventilation air which comes from outside. Okay, so here you can see that there is a CFM multiplied by delta T multiplied by 1.08 multiplied by bypass factor. Okay, then you have a latent load. This is also the same delta H, or you can say that delta T, but it's a humidity ratio difference. Okay, CFM, whatever you calculate based on the fresh air requirement for this particular space, what is the fresh air? So based on that, as per ASHRAE 62.1, you will calculate CFM. Okay, then you can multiply by either temperature difference for the sensible heat or for the moisture difference for the latent heat. You can apply this equation, you will find heat gain through the ventilation air. Okay, then heat gain through the outside air. It's outside, same equation. What is outside airflow? You can calculate and then you can apply this equation. Then heat gain through the people. Okay, number of people multiplied by each people has a sensible load and latent load depends upon the activity. Okay, when you go to the app software, you can see that the people sitting different heat. People are running or walking or doing exercise, different heat, right?
So,
Okay. Now the heat gain through the kitchen appliances. So you can say that there are different type of heat equipments. So you are going to calculate what is the power multiplied by 3.413. You can calculate BTU per hour from that heat dissipation. Similarly, for the heat gain through the motor. Okay. So it depends upon the efficiency of the motor. Okay. Say for example, motor power multiplied by efficiency. Say for example, if my motor works for 95% or 96%, that means the 4% will be the heat dissipation. So that is the heat gain. Okay, then there is a heat gain through electrical equipment. Similarly the same. Power input multiplied by 3.413 to convert into BT per hour. Okay. Okay. Now the heat gain through the lights. Okay, what is that? What is the watts? The light you have 100 watts, 50 watts. What are the watts? Okay, multiply by 3.413, multiply by 1.2 blast factor. This is just for the static current. It will dissipate a heat. So when you multiply, you can get what is the heat here, right? So when you add all the heat, you will get the total heat, right?
yes, sir.
Okay. When you add all the sensible heat, say for example, glass, this is sensible heat, say for example, okay, and wall, assume that you have a sensible heat, okay, and partition, assume that you have a sensible heat, then you have a roof, sensible heat, then you have a ceiling or floor, you have a sensible heat, infiltration, you have a sensible plus latent. So take sensible, then calculate only for sensible load, latent, take it, keep it separate to calculate latent load. Similarly here, sensible load, add it in the sensible load, latent load, add it in the latent load. Similarly, do all the things, then you can be able to get what is sensible load and what is the latent load. So the total load will be sensible load plus latent load, which is nothing but total load, right? Okay, so when you go to the equipment schedule, you can able to find out now what is the total load and what is the sensible load. Clear?
Yes, sir.
Okay. Now, what is the chilled water temperature in and out for the standard comfort cooling? The temperature will be normally, say for example, you have a 5 degree or you can say 7 degree, then that is the leaving temperature from the chiller and entering temperature will be around 12 degrees Celsius. But when you go to district cooling plant, like there are district cooling plants, cooling provider, so based on that, they will provide 6 degree or 14.8 degree. So based on their temperature, you are going to design your equipment. So assume that this is your district cooling provider is giving you, this is my temperature. So 6 degree and 14.8 degree, right?
Yes, sir.
Okay. Now to calculate your chilled water flow rate, there is a equation. Okay. This is the condensed evaporator, right? AHU is nothing but evaporator. Okay. So what is the evaporator equation? TR multiplied by 24 divided by delta T, right?
Sir.
Okay. So TR is what? The total heat. Okay. What you calculate here? It is kilowatt. So divide by 3.516, you will get TR, right?
Okay, sir.
Okay. Multiply by delta 24. It's a just value. Divide by delta T. So what is delta T? This temperature difference, right? In Fahrenheit. Should be in Fahrenheit. So convert this one in Fahrenheit. Then this also convert in Fahrenheit. Then see the temperature difference, right?
Okay, sir.
So you will find out what is the temperature difference. So GPM evaporator is nothing but TR from here multiply by 24 divided by delta T from here. So you can able to calculate GPM, right?
Okay.
So GPM divide by 15.85, you will get liter per second. Clear? Can you note down? GPM evaporator is nothing but
yes, sir.
TR
TR
multiply by 24
multiplied by 24.
divided by delta T. Delta T should be in Fahrenheit and the heat TR should be in tons. Clear?
Okay, sir.
So you can able to get GPM divide by 15.85, you will get liter per second. Clear?
Okay, sir.
Okay. So this is
So
the way. Yeah. This.
Fahrenheit, right?
Yeah.
Okay, sir.
Okay. So now you can calculate what is the uh, total capacity, what is the sensible capacity, what is the chilled water inlet outlet from the district cooling provider, and you can be able to calculate the chilled water flow rate. Okay.
Okay, sir.
Okay. Now you can able to calculate air on coil temperature and air off coil temperature. Okay. So what is the air on coil temperature? It is the temperature what you design for the to maintain the room temperature. Say for example, I want to maintain 24 degrees Celsius. Okay. And 50% RH. This is my comfort. Okay, right? For the inside the space, what temperature you want to maintain? Because whenever you design the fan coil unit, they will ask you what is the temperature you want to maintain. You want to maintain 22 degree or 24 degrees Celsius, right? Or if you go to our green building regulation to maintain the indoor air condition, what they will say? They will say that you have to maintain 24 degrees Celsius and 50% RH for the human comfort, right? So
Yes,
when
sir.
you know dry bulb temperature, when you know RH, go to the psychrometric chart, you can able to get wet bulb temperature. Clear?
Okay, sir.
Okay. So now this is the air off coil temperature, which is the coil temperature. Okay. Now, say for example, if you go to the psychrometric chart, okay, and based on your heat, what is the dew point temperature you should attain, right?
Yes, sir.
Okay. I will tell you one small thing, just for understanding purpose. Okay. Actually, this is a very detailed one, but let me tell you just for that we will see another class. Okay, how to calculate the off coil temperature, but I will tell you as a shortcut. Okay, this is the psychrometric chart, right? Okay. Now, if you go to psychrometric chart, you have a different readings. You have a dry bulb temperature, you have a wet bulb temperature, then you have a humidity ratio, relative humidity, everything, right?
Yes, sir.
Okay. Now, if you go to psychrometric chart, from psychrometric chart, you can able to plot what is air on coil temperature. Say, for example, 24 degrees Celsius and 50% RH. You can plot here, assume, right?
Yes, sir.
Okay. When you go to the dew point temperature, you will reach this position. So, what is the dew point? It is nothing but when your dry bulb temperature and wet bulb temperature in same reading. Okay. That means your air is saturated. Clear?
Yes, sir.
So when you try to cool the air, it will go and meet to the saturated condition. Okay, it will not go exactly the same. It may go little bit inclined. Okay, because you have a both sensible load and you have a latent load, right? When you see the psychrometric chart, you will see there is one curve. Okay, you will find out there is one curve like this. Not rectangular. It's not a rectangular. It will be semicircle. You can say, right? You will find out the semicircle here. Okay, so here you can go. What is the sensible heat ratio? Okay, what is the meaning of sensible heat ratio? You know that sensible heat ratio equation.
I don't know, sir.
The sensible heat divided by total heat. It is nothing but sensible heat ratio, right?
Divide by total heat, right?
Sensible heat divided by total heat is nothing but sensible heat ratio. So when you go and apply in this plot, okay, you will find one curve, one inclined line like this from through this semicircle. It's not a circle; it is a semicircle. When you go and see the psychrometric chart, okay.
Yes.
So based on your sensible heat ratio, if you try to match the value, you will get some inclined line. So when you match that inclined line here, okay, this will go and meet one level, one position, one. It will go and intersect one reading. Okay, so that reading is nothing but your off coil temperature. Clear?
Yes, sir.
So now you can able to understand how to calculate the FC schedule. FC schedule consists of supplier liter per second. So how to calculate CFM now? So CFM, there is an equation. Can you note down 1.08
One.
multiplied by CFM
Multiply by CFO.
multiply by delta T.
Yes, sir.
Clear? This is sensible heat. Okay, we are going to calculate the sensible heat. Okay, now let me open one equation from my PC.
The formula which you said is for to calculate what, sir? The sensible heat.
Calculate the CFM. So
CFM.
you can say that liter per second, right?
Yes, sir. Okay. Airflow. Okay.
Okay, airflow rate. Now let me see that airflow rate. Okay, 1 minute. If you go to my design guideline, I have attached one equations basically. Okay, so this is the equation. Now, can you see what is a sensible load? How to calculate? 1.08 multiplied by CFM multiplied by delta T, right?
Yes, sir.
Okay, load is a latent load, 0.68 multiplied by CFM multiplied by delta W, right? Okay, now
Yes.
if you go to the psychometric chart, you can able to calculate all the readings. Okay, now what is sensible load? 1.08. Okay, you know the sensible load
Yes, sir.
you calculated, right, from the heat, different heat.
Yeah.
Okay, 1.08. So from here you can calculate what is the CFM, right?
Yes, sir.
Okay, multiply by delta T. What is delta T? If you go to your Excel sheet, you know you calculate your air on coil temperature, air off coil temperature. So based on that, you can able to calculate what is the temperature difference, right?
Yes, sir.
So that is the delta T. Okay, then what is the latent load? 0.68 multiplied by CFM multiplied by delta W, right?
Yes, sir.
So this delta W is nothing but moisture. What is the moisture vapor in the on coil temperature and off coil temperature? That you can go to psychometric chart. You can able to understand based on the on coil temperature what is the moisture content. Based on the off coil temperature, what is the moisture content? You can go to the psychometric chart. You can able to find out. We will see how to read the psychometric chart in next class. Okay, but I'm just telling you that go to the psychometric chart. You can able to they get that value moisture content. So go to here, calculate the value, right?
Okay, sir. Yes, sir.
For this one. So you get latent load. So when you add all the load, okay, you know this load, you know this load, right? So based on this equation, you can calculate CFM. CFM is equal to HS divided by 1.8 divided by delta T. Clear?
Yes, sir.
Then this CFM, how you calculate? Latent load divided by 0.68 divided by delta W. So you can get the CFM, right?
Yes, sir.
So add both the CFM, you get total supplier flow rate. So that supplier flow rate is here.
Okay.
Okay, so based on your equation, remember you can able to calculate what is the power input, right? If you go apply in your software, so you can say that how to calculate the power input, right?
Yes, sir.
Is that clear? You have any questions? So this is the way as a consultant we used to prepare the equipment schedule. What is this AHU tagging? You can use the AHU tagging based on your EC reference. AHU minus located in T1 or T1 is a building. GF is nothing but a ground floor serving to main entrance, right?
Yes, sir.
So based on that, you are able to get your equipment schedule. You can ask if you have any doubt.
So what is saturated means?
See, when you say saturated, see, for example, say for example, okay, you have a you say for example, in your surrounding area, you have a air, right? Basically.
Okay.
Okay. So inside the air, what will happen? You have a dry air and moisture air, right?
Yes, sir.
Okay. So say for example, normally in my air, okay, I can say that just for calculation purpose, okay, I have a 1 liter water in the air, okay, right? Okay. Now when the temperature is very high, that means you inside the space in that particular area, you have a sensible load and you have a latent load, which is nothing but moisture air and dry air. Okay. So when the temperature is high, you have a more dry air, right?
Yes, sir.
Okay. When the temperature keep on reducing, then you will have a less dry air, right?
Yes, sir.
The dry air will become less because you're cooling. Your cooling means what? Your 1 liter will be there inside the air, but what it is happening? Your dry air will become reduction, right?
Yes, sir.
At certain point, your dry air will be reduced in such a way that the dry air, like the complete air, there is no dry air. You can say that there is no dry air in that particular air. Okay. That means the air is fully moisture content, full of moisture, like 100% moisture.
Okay.
So when it 100% moisture is nothing but it is a fully saturated. That is nothing but fully saturated. Okay. The
Okay.
air consists of 100% of moisture. That is what relative humidity. When you say 100% of moisture is nothing but the air is full of moisture. So what will happen? That moisture will become water, right? When it is full of water, full of moisture, it become water, right?
Yes, sir.
So that water only condensate drain. Remember when you see the FCU, you have a condensate drain, right?
Yes, sir.
So when the air pass through the coil, what will happen? It will try to reduce the temperature in such a way that there is no dry air.
Yes. Yes.
So that means when
Got
there
it.
is no dry air, that means the dry bulb temperature and wet bulb temperature will be the same temperature, right?
Yes, sir.
So that is called saturated, basically.
Got it.
Okay. So then you can able to, by using electrical equation, you can calculate electrical power based on the CFM. Okay. You can able to calculate your power input based on the efficiency as well. Okay. So basically, there is a equation. Okay. Like you can say that power consumption, like power. Okay. There is a equation also as well that also we can see. Okay, how to calculate the power input based on the electrical equation. You can calculate the electrical load. Okay, so this is the way you can able to prepare the equipment schedule for AHU or FCU or whatever it is, right?
Okay, sir.
Hope everything is clear, right?
Yes, sir. Yes, sir.
So okay, so based on that, you can able to practice in the app. So when you try to enter the value in the app, now you have some knowledge. Okay, so whenever you calculate, say for example, when you apply weather properties, why you apply weather properties? Because you should calculate what is the delta T, what is the outside temperature and what is the inside temperature. Okay, so that is why you require outside temperature and you require, so you are going to feed all the values in the app. So app automatically calculate what is the heat dissipation for each and every component, then it will give you what is the total component. Clear, right?
Yes, sir.
Okay, so you got idea.
Yes, sir.